How are we going to live in the future? How are we going to heat in the future? How can we use renewable energy? An EU-funded project steps up to the challenge. Positive energy buildings through Better Control Desicions. Pebble. 7 partners from 5 countries are researching the possibility of improving the energy efficiency of buildings through the use of intelligent control strategies. The demonstration will take place in 3 different buildings. The new main building of the ION Energy Research Center at the RWTH Aachen University, the building of the Fraunhofer Institute for Building Physics in Kassel, both in Germany, and a building at the Technical University of Crete in Greece. The idea of the control algorithm is based on 3 principles: prediction, adaptation, and optimization. Let's start with prediction. Let's imagine a house which is well heated and has reached its desired temperature. Suddenly, the outside temperature drops and it begins to rain. The temperature in the house starts to drop. Heating up the house again can be energy intensive. Prediction means following the weather forecast and heating up the house before the change in weather, and in this way storing heat in its thermal mass. As such, the comfort level of the user remains constant.
We can differentiate between heavy buildings made out of concrete or brick and light buildings made, for example, out of wood. Heavy building materials can store a lot of thermal energy in its construction, making the temperature response of the building and its rooms to changes of weather, usage or control very slow. Particularly in the case of heavy buildings, dynamic weather forecasts, and hereby especially forecasts of the solar radiation, can be used to increase users' comfort and save energy for heating, cooling, ventilation and lighting.
The building at the Technical University of Crete is a 1-story building with an atrium. Because of the hot climate, the building needs cooling most of the time. Let's continue with the principle of adaptation. We all know the problem. We come home and the house is cold. With increased power, the house is heated up. Heating up before the user arrives can be challenging. Adaptation means automatically adapting to the user's behavior. The house learns when the occupant goes to work and when he comes back.
The integration of user behavior and control strategy is already used in several fields. For example, in very high buildings, the elevators know where and when they should be at certain times.
We want to implement this principle for different types of buildings. We believe that particularly for office buildings, it can lead to high energy savings.
The building of the Fraunhofer Institute for Building Physics is equipped with some of the newest technologies for heating and passive cooling, like concrete core activation and waste heat usage. Furthermore, the building has a high number of sensors. Let's move forward to the principle of optimization. The optimal control strategy is developed with the use of a simulation model. Data is being exchanged between the building, the simulation model, and the optimization algorithm. Data captured by sensors serves as simulation input. The simulation runs and its results are sent to the optimization algorithm, which generates new control parameters. These parameters are sent back to the simulation and the process repeats itself. After several steps, the optimal parameters are found. They are then sent to the building controller.
During the building operation, we're faced with many decisions. When to operate the HVAC system, how to select the set points, whether to preheat or pre-cool, and how to best use energy available through renewable energy sources. Within Pebble, we developed an optimization tool that uses a thermal simulation model to evaluate these possible decisions and select the best strategy to be applied to the building so that energy is saved while thermal comfort is maintained at acceptable levels.
The new main building of the ION Energy Research Center in Aachen is the most complex of the 3 buildings. At the core of its energy concept lays a highly efficient turbocompressor-driven heat pump process that uses geothermal energy as its source of heat. The Pebble system will be used for offices, where it will control the concrete core activation and the facade ventilation units. In conclusion, this is how the intelligent house of tomorrow can help us save more energy while achieving higher thermal comfort levels. Positive energy buildings through better control decisions. Pebble.